Okay, so picture this. You're an astronaut floating out in space.
No gravity to hold you down.
Exactly. Makes you think, how different everything would be, even like basic stuff.
Absolutely.
And that's what we're diving into today, the whole world of physics and those courses, especially the unbalanced ones.
Oh, yeah. Unbalanced forces. Those are the interesting ones.
We've got some pretty cool stuff to work with today.
Yeah.
Yeah, including some parts from a science thing.
Like a knowledge organizer?
Yeah, a knowledge organizer.
Very cool.
So let's see what we can uncover about how these forces actually work and what they mean for us down here on Earth.
Sounds good. And I think starting with that idea of being in space is a great way to think about it because, here on Earth, gravity feels like it's always there.
Yeah.
Constant.
Tight.
But out in space, it's a whole different story. But before we go too far, we should probably define what we mean by unbalanced forces.
Yeah, good point.
It's a bit like, imagine a tug of war, right?
Okay, I'm picturing it.
But the teams, they aren't evenly matched.
Right. Yep.
Unbalanced forces are kind of like that. One side is stronger, and that causes changes in how things move.
Yeah.
Could be a change in speed or which direction something's going, or even whether it starts moving at all or stops.
Okay, I can see that, this cosmic tug of war. But why should we care about these unbalanced forces down here on Earth? It's not like we're floating around.
Well, think about it this way. Every single step you take,
Really?
riding a bike,
Uh-huh.
even dropping your pencil, like just letting go of it.
Right.
It's all unbalanced forces at work. They're like this hidden mechanism behind, well, basically everything we do, and even the more complicated stuff, like machinery and,
So it's not just like equations and theories.
Yeah.
It's like understanding the actual forces that are literally making stuff happen around us all the time.
Exactly.
Okay, I'm starting to see the bigger picture now. So speaking of forces, we mentioned gravity before, the one that keeps us grounded.
Keeps your feet on the ground, yeah.
Yeah. What is gravity really? And how does it actually work?
You could think of gravity as this ultimate cosmic glue.
Cosmic glue.
Yeah, because it's this pulling force, and it exists between any two things that have mass, any two objects.
Okay.
And the bigger the object, the more massive it is, the stronger its gravity,
So the bigger something is.
the more it pulls. Exactly. And the closer two objects are, the stronger that pull is too. So that's why we feel Earth's gravity so strongly. Earth is massive, and we're pretty close to it.
That makes sense, yeah. But if gravity's always pulling things together, why doesn't everything just clump, like in the whole universe? Why doesn't it all just become one giant thing?
That's a really good question. It all comes down to balance. Gravity's always pulling, yeah, but objects that are moving, like planets, they have momentum.
Oh, man.
Yeah, and that keeps them going. It's kind of like when you spin a ball on a string,
Right.
The string, that's like gravity pulling the ball in,
Mm-hmm.
but the ball's momentum keeps it spinning around.
Okay, I get it.
And here's another cool thing. Gravity's strength changes depending on where you are. Like on Jupiter, you'd weigh way more than you do here.
What? Seriously?
More than twice as much, actually.
Whoa, that's wild. So it's like a giant cosmic dance between gravity and momentum playing out across the whole universe.
Yeah, you could see it that way.
That's amazing. Now, our notes also mention other forces like friction and air resistance and water resistance. Do those have anything to do with gravity?
They're actually different, but they're really important too. Friction, in general, is this force that kind of pushes back when two surfaces rub against each other.
Okay.
Like, imagine you're trying to slide a big, heavy box across a carpet.
Oh, yeah.
It's hard, right?
Ugh, the worst.
The rougher the surfaces are and the heavier the object is, the more friction you get.
And that makes it harder to move.
Yep, exactly.
That's why moving furniture is such a pain.
Mm.
So air resistance and water resistance are just like special kinds of friction.
Exactly. They're friction that happens when something moves through air or water. Like, air resistance is what makes a parachute work. It slows the parachute down as it falls.
Off, right.
And water resistance is why fish have those smooth, streamlined bodies.
Yeah.
It lets them move through the water without using a ton of energy.
So streamlining is like nature's way of dealing with friction in air or water.
Pretty much.
It's so cool how we've taken that idea and used it to design things like airplanes and speedboats.
Yeah, that's a great point.
They can go faster, use less fuel.
Exactly. By giving things these smooth, sleek shapes, we can, cheat a little bit, and make things way more efficient.
Love it. Okay, so we've talked about gravity and all these different types of friction, But how do these forces actually create those unbalanced situations we were talking about before?
Well, the key thing to remember is that unbalanced forces always lead to a change in motion. Like a ball just sitting there isn't going to move unless some force acts on it, right?
Yeah.
Like if you push it, and that push has to be strong enough to overcome the friction. But even if a ball is already rolling, it'll eventually stop
Right.
because of things like friction and air resistance.
They're working against it.
Exactly. They're working against the motion, creating that imbalance that eventually brings the ball to a stop.
So it's like a constant battle. Which force is stronger?
Yeah, that's a good way to think about it.
Balanced forces mean things stay the same, either not moving or moving at a constant speed. But unbalanced forces cause things to change.
Exactly. Either start moving, stop moving, speed up, slow down, or even change direction.
Makes sense.
Mm.
Now, I read somewhere that people have figured out how to use these unbalanced forces to work for us with these things called simple machines. What are those?
Simple machines are basically just clever tools that humans invented to help us make work easier, to make things easier to move or lift or whatever.
Yeah.
Like, take a pulley, for example. It's just a rope and a wheel with a groove in it, but it lets you change the direction of the force you're applying. So instead of having to lift something heavy straight up, you can pull down on the rope.
Which feels way easier.
Right. It makes it much easier to lift heavy things.
Cool. What about the other simple machines that were mentioned in these notes?
There's gears, too. They're wheels with teeth that fit together, and they can change the speed and direction of movement. Like, think about the gears on a bicycle.
Oh, right.
They let you pedal uphill more easily by basically multiplying your force.
I never thought of it like that.
Oh.
It's like getting a little extra help from physics.
Yeah, that's a good way to put it. And then there are levers.
Levers.
Yeah, think of a seesaw on a playground. That's a lever.
Right.
Or a crowbar, the kind you use to pry things open.
Right, right.
It uses a stiff bar that pivots on a point to multiply the force you're applying. So you can lift or move something really heavy, even though you couldn't do it with just your own strength.
Wow. So we're surrounded by simple machines, and we use them all the time without even realizing it.
It's like having these secret physics helpers everywhere.
Exactly. This has been awesome. We've learned so much today about, gravity and friction and how they all work together, and even how we can use those forces to make life easier.
Absolutely. We covered a lot of ground.
It's incredible to think about how these forces are always shaping our world all around us. And for our listener, here's a challenge. Take a look around and see how many examples of unbalanced forces you can find.
Good idea.
From the way you walk to the tools you use, physics is everywhere. It's pretty cool when you think about it.
It really is.